Good evening, ladies and gentlemen, and we are back with our next panel discussion with the theme of preventing cyber threats and frauds through blockchain. Now, let me introduce our panelists for the session. First, we have Mr. D. Jana Kiram. He's the director from IDRBT. Mr. Anant Krishnan, founder and CEO from Acumen Technologies. Mr. Atul Kumthekar, he's the head blockchain from Secure Metrics. And Mr. Hitesh Mulani, he's the group CISO from Mahindra & Mahindra. I would request all the delegates to keep posting their questions in the chat box, and we will address selected few questions by end of the sessions. I would request Mr. Kumthekar to take this forward.
Yeah, am I audible? I guess so.
Mr. Atul, sorry to interrupt. We have got Ms. Mehra.
Okay, great. Yeah.
Ms. Mehra, can you hear us? Here we go. Over to you, Mr. Kumthekar.
All right. So first of all, thanks for organizing and giving us all this opportunity to share our somewhat different thoughts on different topic, which is cybersecurity and blockchain. So a lot of people talk about blockchain and supply chain, blockchain and identity, blockchain and voting, and blockchain and of course coins, currencies. But this is somewhat different field, which people are of course near and dear to security aspects, because internet is spreading like anything, to kids, to old age people, to banking, and for all kinds of domains. So I think how blockchain can be useful in a cyber security space will be an interesting topic to listen to. So the way we organized this session was to probably start with a imaginary use case or a scenario where a law firm, typically the way they operate and what kind of data they want to share, the data they want to protect, whether there is some general open source data as against some proprietary data. So I would ask each of us to maybe comment on this imaginary law firm case, and how, what kind of security threats are seriously observed maybe in reality, and what kind of security threats you imagine, and how blockchain can possibly help prevent as well as detect and transparently display it to the stakeholders. Yeah, you can.
I think before we get into the use case, I think for the audience, it would be prudent to, maybe speak a bit about cybersecurity itself as a concept, and then also look at, have Mr. Jankiraman speak about the blockchain technology itself before we actually dive into the use case. Maybe Dr. Jankiraman, if you could probably take the cybersecurity piece, and maybe Ananta could, talk about blockchain as a technology, and then we could get into the use case of how the use case will really pan out. So over to you, Mr. Jankiraman.
Yeah, I think these two technologies, blockchain and cybersecurity, are very important. Though they evolved independently, now people are able to see the synergy of how blockchain fits into the cybersecurity space. I would actually try to give some introduction on what could be, the way we can look at both these technologies as synergic. The first thing is basically all centralized systems have the difficulty of protecting or providing the security because they become vulnerable. Now, whereas the blockchain tends to make the whole system, the distributed system, as a peer-to-peer system. So in that sense, what is the traditional cybersecurity attacks like the denial of service attacks, distributed denial of service attacks. When a single entity is providing the service, it's very easy to actually attack the system. Whereas in the case of blockchain, since it's going to be a peer-to-peer system and the whole system is going to be somewhat distributed and there is no central authority, so the whole thing is maintained as a peer-to-peer system. So it becomes difficult for an attacker to actually take control of the system. It's possible if they're able to control a 51% attack, where they control the majority of the nodes in the system, which is quite impossible in some sense. The system becomes more secured from a blockchain point of view. That's the first thing that we get in when we actually look at blockchain and cybersecurity. The second thing is as a distributed ledger, all the what is happening in the distributed system, especially if you look at transactions, these are actually stored in all the nodes that are part of the consensus mechanism. So they validate and they store. So in that sense, actually data integrity becomes again part of the whole system. So if you need to manipulate any of the transactions, any single node tries to manipulate the transactions, then it actually has to do a lot of work in terms of making changes to the whole chain, the blockchain, and then that's again becomes quite non-trivial and impossible, because possessing that level of computing power to be able to do it. It's possible. Having said this, this is how both these become synergic, but this is not a panacea for the kinds of security problems. The blockchain has its own limitations that we should also be aware of. For example, it is possible to actually do some deeper kinds of attacks. For example, one can withhold the block and then not publish the block immediately, but delay publishing the block, and then can make sure that all the honest nodes accepting the longest chain, a different kind of an attack can be launched. Again, similarly, a node can be eclipsed in the distributed system by actually, if the malicious node is able to take control of all the connections going out from that node, it will be able to eclipse that particular node and not let the blocks propagate. But some of these attacks are very difficult to be launched. Having said that, these attacks are possible in the blockchain as well. It becomes quite difficult. And also, most of the time, what we see in a practical setting is the blockchain. The blockchain itself is not attacked, but the outside entities which are part of the blockchain can get attacked. So in that sense, blockchain does provide a synergic thing to cybersecurity. That will be my introduction to the whole panel in some sense, and when we can start discussing the deeper aspects of the case study and look at how, given a case study, how blockchain can bring in the other dimensions of cybersecurity.
Yeah, thank
Mr.
you.
Mr. Anantha, if you could throw some light on the technology itself and something that you are working on at this point of time.
Sure. Thank you. Thank you, Hitesh, and thank you for the panel. I think Dr. Janaki Raman already talked about the foundations of blockchain. I would like to take it from a data perspective, right? So I think, and even in our use case, one of the largest cybersecurity attacks mostly happen in stealing your identity and stealing your data, right? That seems to be the largest problem most people face in centralized systems. And we have been working on a protocol which tries to address those problems, where the identity and the use and the data can be transferred back to the user. The user owns and controls their identity and data. So, technically, this implemented the technologies that they use for is we use a decentralized identifier to manage yourself. So the blockchain provides you the identity instead of an entity or an organization providing you the identity. So there's no way for somebody to steal the identity, and the identity is stored in the blockchain. And from a user ownership and control of data perspective, uh, primarily the encryption techniques, right? One of the key problems in centralized systems are how is the data stored and managed, and then how do you encrypt, and then how does the user have control over the data? So uh, the encryption techniques are one of the key aspects of how you manage and control your data, and the asymmetric key encryption techniques that blockchain uses. Uh, there are quite a few, and they allow people to share their data for somebody to identify your content, but you still be in control, right? So there are quite a few asymmetric key management techniques which allow you to allow the user to post data in public domain, encrypt that, and keep them in control as well. And the last uh, or the other aspect which is gaining popularity now is the zero knowledge proofs. So what I mean by that is, in any identification mechanism, you need to pass in password or an authentication key to authenticate yourselves. So in most of the central systems today, whether it is any OAuth systems today, whether you use Yahoo, Facebook, whatever it is, you have a central entity where your authentication token, which is your password, is stored. So which obviously creates a significant amount of vulnerability where somebody gets into the system, they are able to access your authentication token, and then you have a serious problem. So with a combination of zero knowledge proofs, where you don't send away the authentication token, so you just prove that you have the authentication token, and so use zero knowledge proofs along with blockchain and key management techniques to provide an environment where user owns and manages and controls their data themselves. So the passwords are never stored anywhere. The data is fully encrypted, and the provenance of access is on a decentralized ledger. And the last piece of the puzzle, which is getting popular now, is how you store the data. Right today, data in the internet world is stored using location addressability. What I mean by that is, when you want to pick a data, you'll have to go to a place and pick up the data. So, for example, this video today is streaming from a server, and the server has got an address. So obviously you can hack that server, and it cannot be a peer-to-peer situation. But the new technology that is gaining popularity is content addressability. You don't search a network, a peer-to-peer network, using its name, but using its content. So it's a very interesting technology. So the data could be anywhere on the network, but then you just don't have to have a location. You can use content addressability. So with a combination of zero knowledge proofs, decentralized identifier, content addressability, and blockchain and encryption techniques, user can not only mitigate the infrastructure threats which blockchain provides, but also the ability to own and control the infrastructure so that they can manage their environment better and personalize it better.
Atul, could you throw some light on some business cases that have come your way in the organization that you had?
Yeah, so I'll basically talk about how I am looking at cybersecurity and blockchain interaction. So I basically divide the cybersecurity world into two zones. One is the detection, and the second one is once it is detected, how do you transparently communicate that vulnerability incidents or whatever to the stakeholders without hiding anything. And that the second part is more kind of, I'm more passionate for this second part, because a lot of compliances that are coming up are kind of dictating all the companies to disclose their vulnerability attacks or data leaks or identity thefts transparently to the public also. And that is where I think blockchain is going to be instrumental. And I look at it as a kind of a special IoT blockchain use case, which is very common in blockchain world. So all these vulnerability detection algorithms or logics or programs, they will kind of serve as IoT endpoints, and they will push data directly to the blockchain without any human intervention or anybody entering data. And that's the only way I see that that kind of transparency can be achieved with all the stakeholders. So that's how I'm looking at it. And the business cases, I mean, we will see later on some imaginary business use case for lawyers, firms. And every month we will see at least two or three big news coming up in the media that this data was hacked, this identities were leaked, and all kinds of things. And if you just look at the Times of India or Economic Times, you will definitely see 3 to 4 such news items every month, definitely. So how can we stop that? If at all it happens, how can the stakeholders be informed? If not immediately, but at least in the annual report or whatever. So the stakeholders should be aware of all this. That's where I'm going to focus. Yeah, Hitesh.
Thanks, Atul. Yeah. I'd like to, so at one point of time, if I was to look at maybe, 6 or 7 years ago, when blockchain as a technology started really coming into prevalence, and of course, Bitcoin made it, as famous as it is today. Um, there was this whole buzz that blockchain is the new normal. It's going to change the way we do things. It's going to change the way we do transactions and all of that. There was a lot of chatter about it. There was a lot of noise on the internet about it. What we've realized as heads of security, as heads of organizations, that it has certain use cases that are mind blowing, but it is not as big as we probably made it out to be a few years ago. Right? It has its limitations. Like every technology, the hackers have broken into this one as well. So that's always going to happen. But I think the important part is that it has certain very strong use cases. So if I was to quote some from the manufacturing sector, right, where we're doing some research on, we have certain projects that we're working on the blockchain side. One of the areas that we're looking at is machines as a service, right? It's the new terminology MaaS. So it's machines as a service, where you don't take on equipment, you don't buy equipment. The smaller manufacturers, the ones who are starting afresh, who've got smaller operations, can choose to take machines on hire and only pay as they consume those machines. So let's say you buy an air compressor, you only pay by the amount of air that you actually, push out, right, in cubic feet. And you could actually turn around and have a model that works on that manner. Now, the question that comes up is, how do you track the utilization of that machine? How do you track, the service history of the machine? How do you track the breakdowns on the machine? Because you can't have a person standing with the machine at the location where it's being operated. So in models like this, there have been very interesting, areas where there are certain components that can actually be mapped back. You can create a so-called shadow machine and actually have the changes tracked back onto that shadow, which is controlled in terms of integrity by blockchain, and then go about keeping a complete track record of everything that's happening with the machine, including utilization, based on which the chargebacks are going to happen. So it benefits both sides. It benefits the company that is utilizing the machine as well as the company that has put it on hire. So I think that machine as a service is something that is picking up in prominence. Then and then you have, obviously, when you look at the supply chain. Um, so when you take blockchain into cybersecurity, now cybersecurity, everyone's heard those buzzwords, right? It's CINA, confidentiality, integrity, availability. When you take manufacturing, it's always the other way around, right? Those concepts go for a complete flip. It becomes availability first, availability of machines, availability of processors, and availability of raw materials, right? Then comes the integrity of all of the components that are going into your system, or how your machines are working and all of that. That's the other big thing. And then comes the confidentiality part of it. There's very little that's confidential when you have a certain machine working or you have a certain process working, right? That's more at a design stage. But in the actual operational area, in the operational technology area, it's more about availability, the integrity of those processes working to a T, a machine cutting the way it is supposed to be cut and spinning the way it is supposed to spin, and nothing different. A slight difference there, and it can actually cause, it can be a safety hazard, right? So I think when you take all of these components into play, there are certain use cases that are being explored in those areas and very successfully, where we're actually saying, can we ensure quality checks of every component that is coming in? Can we ensure that machines are running exactly the way they were configured and there is nothing that can be tampered with those settings? So every version that is there of configurations can actually be controlled through, and there are multiple, every change that gets into a machine can be actually tracked back. So I think there are a lot of interesting use cases on the OT side. So we call it operational technology. It's not just IT, which is your traditional cybersecurity, but also cybersecurity on the operational technology side, um, and how these use cases can be taken forward. So I think there are a lot of applications for blockchain in general. Uh, they come more to the fore, like Ananta and Mr. Janki Raman explained. It's also comes into the domain of cybersecurity in a big way, and there are some serious use cases on how they can blockchain as a technology can be applied back. But I think it has a very strong flavor of business that needs to be applied back to the entire context when you're looking at blockchain as a use case.
Hitesh, see, no, you talked about the manufacturing use case, I would like to bring no, the use case of 5G use case lab for banking, where we are looking at blockchain and cybersecurity. Uh, Probably that's also will be very interesting because it will be in the financial sector. As we know, with the 5G, we're going to have a real bandwidth connectivity. And then one of the key things that we're interested in establishing with the 5G use case lab at IdeaBT is, these are funded by Government of India, and then this lab is funded by Government of India. And the idea is to actually do a network slicing and create a private 5G network for financial transactions. Now, one of the things is to support blockchain on top of the, at the application level for doing transactions is one thing. The other thing is to actually use the blockchain to secure the 5G network itself is a very interesting thing, because if you look at all the network elements, which include the network elements, which is the microservices part, which will be running as a stack, that itself need to be secured, because you don't want a single point of attack or failure at the network layer level. So you're going to use a blockchain there for the authentication purposes, and make sure that all the services will run in a secured fashion in the 5G network itself. So in that sense, you can create a completely secure 5G infrastructure, digital infrastructure for financial transactions. And that's going to be really a game changer. If you look at the future, the way the financial inclusion is happening, I think security is going to become paramount for people to be trusting on the financial infrastructure. Any small loophole in terms of the security, for example, including the smart contract vulnerabilities in smart contracts, which led to for example, in some cryptocurrencies, taking away the money from the chain itself. So those kind of things need to be completely addressed in that kind of a configuration. So I see that's a very powerful use case for the blockchain, from the financial sector, both for setting up the network security and also at the application layer level where the financial transactions itself will be going through. The second very important use case I see is a lot of banks are developing the AI ML products, and security of that AI ML itself going to become an issue in future. For example, if there is somebody knows that you are actually collecting the data and modeling your system, and if he starts attacking the data source itself, then your model itself will go wrong. That's where blockchain fits very nicely, because now all the data, there is no tampering, and then only data integrity will be maintained by the blockchain. So in that sense, it's very, the use case of how you can protect your AI ML systems using blockchain, in my opinion, is also going to become a very powerful use case in future. Right? I thought I'll bring both these other two use cases also to the attention of this panel and the audience.
So one of the use cases that we wanted to discuss, Atul brought about, was the law firm use case, right? How do you securely manage data which is
Yeah,
specifically there
I'm
in a
sorry.
law
I
firm?
could just pipe in. Sorry, I came in late, but then I was just letting the session flow because I didn't want to obstruct it. But so now, as far as this, we have 10 minutes left. So as far as this use case goes, just so that I can articulate it, and then everybody give their like envision solution stack. That let's say there is a law firm which collects sensitive confidential information from its clients. It has to store that data. It has employees which are working all over the country, so through remote devices, right? It's all connected to a centralized database and server. Needs to store that data and then also submit to, let's say, a court, or let's say to a patent office, or it needs to make, submissions. So at the end of the day, the clients of the law firm are really depending on the law firm's integrity and technology to keep their data safe, to make sure it doesn't get leaked, make sure the server doesn't get hacked. Now, where is the cross section of blockchain technology to come in and alleviate some of these concerns that a law firm has, and indirectly its clients have? And yeah, so and we can just start with Atul, then we can go to Ananta, then we can go to Professor, and then we can close out this session at the end of the 11th minute with Mr. Hitesh and his inputs on this.
Yeah, so quickly, I've been attending other sessions and I've seen the similar insurance case where the speaker said that there were 14 insurance companies that came together under government food, and they formed a consortium and they created two blockchains, one for life insurance, one for general insurance, and they hope to interact within those. So something similar may happen with the law firms also. So there may be a central blockchain to which individual law firms may collaborate with or exchange data or submit data both ways, take and give. And then, so that's the way I see. I think most of these security issues also probably will be handled. And the encrypted data, someone is even asking, is the blockchain data encrypted? So we can always keep the data encrypted and just put the hashes on the blockchain. So even if anybody hacks the data, they will only get the encrypted data. It's a completely useless data for any hacker as well. So those are my few quick points. Due to short of time, I'll just hand it over to next. Anant.
Yeah. Thank you, Atul. I think you hit the nail on the head. I think from a security standpoint, Shika, I'll break it into two pieces. One, obviously, the infrastructure standpoint. The more you have a decentralized peer-to-peer system, the better it is from a DDoS attack standpoint. So from infrastructure standpoint, blockchain is inherently superior to a centralized system. But from a data standpoint, which is your question, there are three aspects on which primarily you have problems. One is identity and provenance and who accesses the data, right? The employees access the data, you know who accesses it, and you should know they accesses it, right? So as I told you, a decentralized identifier which cannot be hacked, and the provenance and the chain on data access is the starting point. Then from a data storage standpoint, at rest, obviously you need to have a proof of the data is not being tampered with. So you can have encryption techniques, which allows you quite a few of encryption techniques where, as I told you, without sharing the password, you'll be able to do an end-to-end encryption. So data at rest is encrypted. So you have you have confidence on who access the data and the tamper-proof provenance on the data, secure at rest, and obviously you can optimize it using content addressability and hash, and that hash can be written on the chain. And finally, ownership and data sharing. So you said data has to be shared. So the best way to do that would be to every piece of data is a separate token, right? You can tokenize the every file is a non-fungible token, and then the token who is with somebody at any given point of time. And whenever I want to share a file, I pass the token around, which is cryptographically secure and written on the chain. So you solve all the three problems: data identity and provenance through decentralized identifier and blockchain, data security at risk by using encryption techniques and content addressability, and finally data sharing through a combination of a non-fungible token and a cryptographic wallet, so that people can pass that file from one wallet to the other. And obviously, all of this protected by the peer-to-peer decentralized infrastructure of a blockchain.
Yeah, that's great. Actually, I was hoping one of you brought up NFTs to tokenize the document and thereby control its
Yep.
sharing and that. That's awesome. Okay, and Professor.
Yeah, I think I would like to. I think both Ananta and yeah, the other previous panelists actually had looked at very clearly, what is the kind of use case this is going to be. But I would like to actually look at slightly differently. For example, you would like to also outsource this data to the cloud. And then I think the cloud security using the blockchain, because especially all the various parties might be accessing the cloud, and that could be a more common IT infrastructure that might become most common. But in that case, the audit trail and then who is accessing it, as rightly brought out by Ananta, and then also authentication, authorization, all these issues which are part of this kind of a use case, can be maintained, as part of the blockchain system in the cloud itself, which means that the cloud security itself can be enhanced by using the blockchain, and that inherently provides all the necessary benefits that are needed in an application like this. Having said this, I would feel that when there is only a single entity which can control a lot of things, blockchain probably is an overkill, because the consensus mechanisms, especially the proof of work, consensus protocol, is very, very expensive. When it is not really required, we should not be inserting that into the system. For example, when you want to kill a mosquito, a hyperbole, you're certainly not going to use an AK-47, and you will do more harm to yourself than, to the system. So in that sense, blockchain could be an overkill in some cases. So you don't want to introduce that unless you understand the expensive nature of the consensus protocols. Of course, a lot of research is going on how to actually make these consensus protocols better, and that's going to be a continuous work right now. That's where basically the blockchains need a lot more research coming from, and then so that's where I will stop, and I will say that this use case is slightly a contrived use case in my opinion, because the legal form can control everything and provide in a much easier sense than multiple entities where the trust is required. That's where basically the blockchain fits much more naturally. Okay, with that I'll stop.
Yeah, so I'd like to, I think technically Ananta has covered it, and, Professor Jankiram has pretty much, kind of put it in context. that yes, if it were a consensus-based model, multiple entities is when this would really fit in. But if you were to look at the law firm in isolation, then I think what also needs to be kept in mind that is irrespective of the consensus-based, I would like to tell the audience that we're only talking about one aspect of cybersecurity. When you look at cybersecurity, blockchain is just addressing one small aspect of it. It does not address all the cybersecurity issues that come in general. When it comes to access, when it comes to an outsider reaching into your organization, you still need firewalls. You still need other technologies to protect your network. You still need other technologies to protect your periphery. Blockchain is a has a particular use case, and in that context, it is in some of the examples that Professor Jankiram gave, Anantha and Atul have given. I think it fits in beautifully, and those use cases are really worthwhile, to be explored. Thank you.
Absolutely. So I think we've run out of time. Do we have time for questions? Do we have questions?
No, Miss Mehra, we'll have to wrap it up now.
Okay. Okay. Thank you, everyone. And maybe
Thank
you
you.
can send questions to us offline if there were some burning questions that someone needed to ask. Then I'm sure the esteemed panelists, they would be happy to take that later.
Of course, we'll share that with you. I would like to thank you, Ms. Mehra, for joining us, and a special thanks to all our panelists and our audience for joining us for this interesting panel discussion. We are signing off, but we do still have other exciting panel discussions planned for you. Thank you, everyone. We are signing off.
Thank you.
Thank you, everyone. Thank you.
Thank you, everyone.